This is reading a scale just as you would in maths. So you just check how many divisions there are between the readings that you've got. So here between 80 and 90 we've got clearly 10 divisions between those two. So each small division must be 1. The one halfway is the 5, so I've labelled that 85. So it means the reading, which is where the black line of the end of the syringe is, that would be 83. The beginning of the question says that this is an investigation to do with how concentration affects the rate of reaction. So that clearly means that the first of these is not one you'd want to keep constant. You don't want to keep the concentration constant. You want to vary that. The mass of magnesium, yep, you want to keep that the same, so it's a fair test. Temperature, well, that's going to affect the rate of reaction, so we want that to stay the same. The time for the reaction to end, well, that we're going to be measuring. And the volume of gas collected, we're going to be measuring. So the volume of gas is our dependent variable. So we don't want to keep either of those constant. So the two that are ticked are the correct ones. In the GCSE, the examiners are very fond of popping in an anomalous result in a table of data and then asking you to find the average of a set of data. So in this, if you look across the rows, you'll find that the four tests are fairly consistent, but for the one you're being asked about, that's the 40, you've got test 1 of 46, test 2 30, then the other two 47 and 49. So the 46, 47 and 49 are all very close together, but the 30 is way out. So that is anomalous. When we're finding an average with an anomalous result in there, we ignore the anomalous result and you find the average of the other three. So you add those up, 46, 47, 49, divide by 3 because there's 3 values there, and that will give you a value of 47.33. You're then asked to do that to 2 significant figures. So 2 significant figures, you should have 2 numbers there, starting with the first number, as long as it's not a 0. So in this case it's a 4. The second number is a 7. You then look at the next number, which is the 3. If that number is 5 or up, 5 to 9, then you would round up to 48. If it's a 4, 3, 2 or a 1, you would then round it down and therefore your answer would be 47. Now it's essential in questions like this that you get into the habit of drawing lines onto the graph provided as I've done here. So you've been asked the rate of reaction between 0 and 50 seconds. So from the 50 seconds I've drawn a vertical line up to the curve and then turned left across onto the y-axis. So I've got 50 seconds corresponds to 80 cubic centimeters of gas. Therefore, I've got my formula there. Mean volume of gas, well, that's going to be the 80. That's going to be divided by the time taken, which is 50, because it's gone from 0 to 50. That gives you a value of 1.6. So the rate of reaction is 1.6 cubic centimeters per second. In this sort of question, it's worth having a look at how many marks are being available for the question. So in this case, we've got 3 marks, which means they're looking for quite a lot of detail here. Being asked how the rate of reaction changes between 0 and 160 seconds. So I've started off there by just making a general statement that the rate starts off being high, and then the rate decreases till you get to 110 seconds, and then the rate is 0. So the reaction is actually finished. What I've done then is I've done a couple of calculations. I've just picked a a part of the graph towards the beginning of the time, so I've chosen between 0 and 20 seconds. I've worked out the rate there to give me 2.3 grams per cubic centimetre, and then I've then chosen another one between 80 and 100, calculated the rate there. It comes to 0.2 grams per cubic centimetre. So I've illustrated my first sentence with two calculations, which gives me the extra marks there. For this sort of question, you can either do this by looking for the correct answers or by eliminating the answers that are clearly wrong. Now the question says we've concluded that the rate of reaction is greater when the concentration of acid is higher. You've been asked, why is that? First one there says the particles are moving faster. You're saying, no they're not. I'm varying the concentration, not the temperature. So the particles are moving the same speed. Second one, particles have more energy. No, I'm changing the concentration, not the temperature. So that one gets eliminated. Surface area of magnesium smaller. No, I'm varying the concentration, not the surface area. So that then means I've then eliminated the first three. I've got the last two, so we need to check, are they actually correct? So concentration, do I have more particle collisions each second? Yes, I do, because if I have a higher concentration, the particles are closer together, and therefore there will be more collisions per second. Last one, more particles in the same volume. Well, that's what concentration means. If I have a higher concentration, I have more particles in the same volume. So last two are correct. There are three tests for gases that you should be familiar with at this stage. They are for carbon dioxide, oxygen and hydrogen. You need to really have these embedded in your head. So first of all, the test for carbon dioxide is that you add it to lime water, which is a colourless liquid, and when you do that and carbon dioxide is present, the clear liquid will go a milky white colour. Secondly, the test for oxygen, you take yourself a splint, that's the little piece of wood you use for lighting a Bunsen burner, you light it, you then blow it out and put it into the gas, and if the gas is oxygen or contains a high proportion of oxygen, that splint will relight. The third one is hydrogen. For this one you need a lighted splint. You insert the lighted splint into the gas, and if hydrogen is present, then you will get a squeaky pop sound. This is a question about dependent and independent variables, and it's important that you have some way of remembering which one of those is which. One way I teach the difference is that if I am the experimenter, then I change one of the variables. I change the I, or independent variable. So the independent variable is the one that I change, and the dependent variable is the one that's given me by the experiment doing what it's doing. So in this situation here, I'm changing the concentration, and you can see that's at the beginning of the question. It tells you that, and the dependent variable is the time it takes for the cross to no longer be visible. The other variables listed there are not dependent or independent. Those are things that you would want to keep the same. So those three are called control variables, and you control those in order to make the results valid. Just bear in mind that this question, having the information "do not use any anomalous results in your calculation," is unusual. Generally speaking, they won't tell you that, and they'll expect you just to notice. So in this, we ignore the 78 because it is significantly different from the other two values, the 41 and the 43. Average those two and you'll get 42 seconds. Notice here that once you've plotted the points, the points at 60 seconds seems to be significantly lower than the general trend. And so when you do your trend line, you don't take any notice of that one. You treat that one as being anomalous, and you put your curve of best fit generally through the other points. In this question, you're given the equation to work from. The rate of reaction is the mass lost in grams divided by the time taken in seconds. In the table, however, you've got the time taken in minutes and seconds. So in order to use the equation correctly, you're going to have to convert that time to seconds. So 60 seconds in a minute. 2 minutes would be 120 seconds. Add on the extra 30, that gives you 150 seconds. So then you do your mass. It's 9.83 divided by the 150. That will give you about 0.066 grams per second. So this question here is about the effect of temperature on the rate of reaction, and you've got to tick two of those items there. So again, you can go through this either positively, these ones are definitely correct, or you can eliminate the ones that you know are not correct. So let's just go through in turn. So we've got the particles are more concentrated. So that is implying that if you raise the temperature, that's going to affect the concentration. Well, that's just not right, because the concentration is to do with how many particles there are in a particular volume. That's not going to change if you warm it up. Second one, the particles have a greater mass. Now this is actually a misconception that some students have, that if you warm up some particles, they somehow expand, and if they expand, therefore they've got to have a greater mass. Again, that's not true. The mass of the particles is going to be the same regardless of what temperature they are. Third one, particles have a larger surface area. No, they don't. It's the last two that are going to be correct. If you warm up the reactants, the particles are going to have more kinetic energy, so they can move around faster. They're going to have more energy. So those two are the correct answers.